Marcus is the star of his high school's basketball team. Opposing teams foul him often, but he makes his free throws 88% of the time. If Marcus takes 6 free throws in one game, what is the probability that he makes at least 2 of the attempts? You may assume the attempts are independent of each other. All right, so it's a probability question, and they're asking us for the probability he makes at least 2 of his 6 attempted free throws. So whenever we see a probability question, we have to ask what type of probability is it. If there's more than one trial or more than one selection, we want to think of multiplication rule or perhaps binomial probability, at least in the context of the topics we've learned in this course so far. So one rule of thumb is that you should probably consider that it's binomial probability if not all of the attempts are turning out the same way. So for example, if they said he's taking 6 attempts and he misses all of them, you could do that with multiplication rule of probability pretty easily. If he says they're taking 6 attempts and he makes all of them, again, somebody's taking 6 shots and he makes all of them, then that's multiplication rule of probability, or at least multiplication rule of probability can be used to solve it quite easily. However, if they say that he's taking 6 shots and he's only going to make 2 or more, or 3 out of 6, etc. In other words, if they're not all turning out necessarily the same, then at that point you should probably consider using binomial probability. And all you have to do is go through the binomial probability checklist to see if it is a binomial experiment. So first thing we'd say is, can we express a random variable that counts the number of successes here? Sure, I think we can say that x here would be the number of attempts that he makes, or the number of times the ball goes into the basket successfully. So x would be equal to 2 or more, right? Because at least 2 means 2 or more. Right, if I said to you, you need at least a C to pass this course, it means a C or higher. So at least 2 means 2 or more, or 2 or higher. And 2 or more in this case actually means what? 2, 3, 4, 5, right? So it'd be basically 2, 3, 4, 5, or 6 attempts going in. Okay, do we have a fixed number of trials? Absolutely, he's taking 6 shots, so we know that it's clearly 6 attempts. Do we have a probability of success? And does it remain constant from trial to trial? I think it does. They say there's an 88% chance of success, so 0.88 for the probability of success. That means the complement is just 0.12 or 12%. How do we get that? We just do 1 minus the 0.88, right? And that will give us our 0.12. So the probability of failure, or Q in this case, is 1 minus the probability of success. All right, very good. Now, we also have to make sure the trials are independent of each other, but they did tell us that in the problem, so we don't have to worry about that. Okay, good. So we have now an approach that will work, binomial probability. The problem is that this problem would require us to calculate all of these probabilities. We'd have to do probability that it's 2 plus the probability that it's 3 plus ... all the way up to the probability that it's 6. And if you count that out, that's 1, 2, 3, 4, 5 different probabilities that all have to be worked out. That's a little time consuming. We don't want to have to do it that way. But if we went ahead and said, hey, look, the probability that it's 0 plus the probability that it's 1 plus the probability that it's 2 all the way up to 6, that has to add up to 1. Has to, because we've covered all the cases that are possible. When he takes 6 shots, he either makes no shots, right? He either makes 1 shot, 2 shots, 3 shots, so on and so forth, right? So we've covered all the possible cases, so we must have all the probabilities, so we must have a total probability of 1 for this equation. Now, if that's the case, and we want this portion, that's the portion we're trying to solve for, then we can just subtract this portion away from 1. In other words, if I do minus the probability that it's 0, minus the probability that it's 1, I should end up getting my solution, right? Because then I'll be left with the part that I want. So the way to solve this, the way to solve the probability that x is greater than or equal to 2, right, 2 or more, is equal to 1 minus the probability of 0 minus the probability of 1. If I take those probabilities away from 1, I'll be left with the probabilities I want. Okay, and then you can do that with either a probability table like the binomial probability table, or you could do it by hand. I'm just going to do it by hand because it's not that hard to do by hand here. So probability that x is equal to 0, you actually don't need to use binomial probability for that, but we could fill it in if we wanted to. I'm going to skip doing that though, because it'd just be time consuming. If you think about it, 0 means 0 successes, right? That means every attempt is a failure. Well, here's the chance that he fails to make his shots, so 0.12. If he's going to do that every time and the trials are independent of each other like they said, then this just has to be raised to the 6th power, and that is the probability of 0, right? That means he missed every shot. Each time he took one, the chance he would miss it was 12%. If you raise that 12% to the 6th power, that's the chance he misses all of them. Okay, and then we have to work out the probability of one success. So we'll use the binomial formula for that. So out of 6 attempts, we're going to choose 1 to be successful. The probability of a success is 0.88, right? And we're going to raise that to the 1 power because he'll make 1 shot out of 6. But then he's going to miss the other 5, so the probability that he misses is 0.12, the leftover amount of probability. And then out of 6 shots, if he only made 1, 5 of them will be left, and those 5 shots will be misses. So that's the equation that we need to plug into the calculator. So if we put all this in, we'll have our answer in the calculator. So let's go ahead and do that. It'll be 1 minus 0.12 raised to the 6th power minus 6 choose 1, which is just 6, but we can type it in 6, and then in my calculator I come over here and bring it up in that way. So 6 choose 1 times 0.88 to the 1 power. I don't have to put it to the 1 power, so I'm just going to leave that alone, and then times 0.12 to the 5th power. Press enter. And there's my answer. It's 0.99986, so on. So it doesn't work out to be exactly 100%, because if we round off to 3 places, it's going to end up being basically 1. I'm going to go ahead and just round this off to 4 decimal places. That way it'll be 0.9999, right? So the answer we get at the end is 0.9999. So there's a 99.99% chance he makes at least 2 of his attempts.